let's go to explain what is the slope of a rectilinear line. I'm going to do all the steps like I was a student, so you can understand what I'm asking exactly. I'm asking explain what is the slope of a rectilinear line. Well, I would say the slope is the measure of how much, this is y, this is x, what is the relation of delta y divided by delta x. And let me change here the color. I don't like the black, I like the white. So delta y divided by delta x. So what it means, this relation, this is the slope. Okay, if I have x and t, the slope that I'm talking about is delta x divided by delta t. What does it mean, delta y and delta x or whatever? You have 2 points, point x1, y1. This is the first point. You have the second point, x2, y2. What is the second point? Is here. What is a rectilinear line? A rectilinear line is a line that maintains the slope constant. So this is the rectilinear line, and the ratio delta y is this, divided by delta x is constant. This is the basic fundamental thing of a rectilinear line. The ratio delta y divided by delta x is constant. So delta y is y2 minus y1. What is y2? Y2 is all this height. What is y1? Y1 is all this height. So what is y2 minus y1? Y2 minus y1 is this height. Y2 minus y1. The same for delta x. With delta x is x2 minus x1. What is x2? From here to here. What is x1? From here to here. What is x2 minus x1? From the initial point to the final point. This is x2 minus x1. y2 minus y1 goes up, and x2 minus x1 goes to the right. And what is delta y divided by delta x? y2 minus y1 divided by x2 minus x1. Perfectly. So I can give an example and explain that how I can calculate the slope. I can also put up another point here and make the slope make the slope between these 2 points. This point, P1 and P2, P1 and P2. And now the slope will be exactly the same because it's the same inclination, the same slope. So let's go now to the third part. Explain how to construct geometrically speaking a rectilinear line giving a point and a slope. Okay, they will give me a point, P1, and they give me the slope. The slope is delta y divided by delta x. Then delta y is related like m times delta x. So if the delta x is 1 and the slope m is 3, so delta y will be 3 times whatever I do in the delta x. So I will move from the point initial, they give me an initial point, I will move, let's say that the point that they give me, the point 1, 3, I will move delta x 1. So delta y will be 3 by 1, 3. 1, 2, and 3. So I'm here. Now I will move again 1 unit to the right, delta x equal 1. So delta x equal 1 means delta y, in this case that the slope is 3, 1 by 3. 3 by 1, 3. So again, 1, 2, and 3. So the rectilinear line is being constructed like this. Now that we have said how the rectilinear line is being constructed, can we find the equation of the rectilinear line? So the equation is m is equal delta y divided by delta x. So delta y is m by delta x. So delta y is y final minus y initial, y0. I named the point y1 like y0 is the same, and the point y2, the final point, generic point y, equal m by x final dx minus x initial. So I found the equation of a rectilinear line y0 plus m by x minus x0. This is the equation of a rectilinear line. Perfect. From the equation, we remake the equation internal. And now they say do the same thing with x and t. Let's go to do the same thing with x and t. I have the variable x, that is position. This is the 0. This is the time. I start with a point. Let's say the point t equal 1, x equal 2. Okay, I start with a point. So I'm going to move the point in the case that delta x, the vertical distance, divided by delta t, the horizontal distance, is equal 3. So delta x is 3 times delta t. So if I start at the point t equal 1, x equal 2, and I move delta t equal 1, it will mean that delta x is equal 3. So I move 1 to the right, delta x is 1, delta t is 1, delta x is 3, 1, 2, and 3, and now I am 3, 4, I am at the position 5. So I was initially at the position 2 at this time. And now at this time, I'm now at the position x equal 5. So I'm here at this point, at the point 2, 5. Let's go to do it again. I move now 2 seconds in the horizontal. So if I move 2, if delta t is 2, delta x is 3 times delta t. So delta x will be 3 by 2 will be 6. So I'm further. So I will move 1 and 2 seconds. Now the point delta x will move 6 units. 1, 2, 3, 4, 5, and 6. So I'm here. So I was at the 5. I was here. I start here. And at t equal 4 seconds, I will be now, I have advanced 6 meters more, so I will be at 11. So this point will be the point 4, 11, meaning that t is 4, x is 11. So the object is moving. And what is the equation of the rectilinear? What is the graph of the rectilinear line? It's here, it's here. Okay, this is the graph. And what is the equation? I will do the same thing. Equal 3. And the initial point P0 is the point 1, 3. 1, 2, sorry, 1, 2. What is the equation? Well, delta x divided by delta t is x minus x0, x final minus x initial. So x final could be the 4, or could be the 2, or could be x. And t final is t, sorry. sorry, a t final is t here. Sorry, x final can be the 2, x final can be the 5, x final can be the 11, or maybe can be the x. So delta x, the delta x that are here, the delta x that are here is x minus x0 for any x. For any x that you place here, x, the delta x from the initial point is x minus 2. So x minus x0. T, delta t, will be t minus t0. And delta x divided by delta t is 3. So let's go to put in the data. X minus the point P0 is t equal 1, x equal 2. So x0 and t0. So it will be x minus 2 divided by t, generic variable, minus 2, minus 1, t minus t0 equals 3. And from this equation I find the x is exactly the same thing. 3t minus 1 plus 2. And this is the equation of this rectilinear line. So I'm done. Let's go to the next question. In terms of x, what is the name we give to the slope? The slope is delta x divided by delta t. And what is the name that we give to the slope? Velocity. Oh, the velocity before, when was the y and the x, we didn't give any name to the slope. We just say the slope. Because delta y is in meter and delta x is in meter. But the relation delta y divided by delta x is equal meters divided by meters. So they have no units. But now the velocity, the slope, have units because delta x is a difference between meters. 5 meters minus 2 meters, 3 meters. So delta x is in meters. Delta t is the difference between 2 times, 2 intervals, 2 times. 5 seconds minus 2 seconds, 3 seconds. So delta t is in seconds. So delta x divided by delta t is in meter per second. The measure of the velocity is meter per second. Perfect. Give examples of motion at constant velocity. I would say imagine that this is imagine this is a guy, and the guy is moving with velocity 30 meters per second, and the guy is initially at the position x0 equal 5 meters, at time t equals 0. Write the equation of motion. So the x will change. He will not stay at 5. He's moving 30 meters. Let's go to put here 2 meters. 2 meters per second. So he's moving at 2 meters per second. So after 1 second, he will be at 7. So the guy at t equal 1 will be at the position x equals 7. At t equal 3 will be, at t equal 2, will be at the position every second he moved 2 meters. So he started 4, so he ended at 9. But this equation is the equation x of t equal x0 plus v by t. This is the equation that we found before. So x of t is x0, 5, plus v, 2, t. Let's go to check it. If t is equal 0, if I plug in t equals 0 here, x will be the 5. Oh, perfect. If t equal 1, 2 by 1, 2 plus 5, 7. X equals 7. Oh, the object is here. And the representation of the graph in x and t will be that at t equals 0, he is at 5 meters. And he's moving with a slope 2. So this is the representation when t equals 1, he is at 7. When 2 equals 2, he is at 9, etc. So I will explain things like this. Let's go. Now we study when the velocity is not constant. This is the point that I want to. Now we go to a graph v of t. And we want to study when the velocity is not constant. In the previous example, the velocity was constant. Now the velocity is not constant. Velocity and time is not constant. But the velocity could do also like this. We don't study this case. We don't study this case. We study the case when the velocity is a rectilinear line in the space velocity time. So in a way that now the velocity is increasing. Every time is increasing. So it has a slope. What is the slope in the graph v of t? Is delta v divided by delta t. And this is the slope. And how we name this slope? We name this slope as the acceleration. And we use the unit for acceleration meters per second squared. I have explained in class. So from this equation I have v final minus v initial divided by t final minus t initial. I put t initial equals 0 equal a. From this I have that v final, the equation of the rectilinear line for the variables v and t is this equation, where v0 is these things. v0 is the initial velocity at time t equals 0. Perfect. And now that we have done the equation of a rectilinear line, we know that the slope is the acceleration in the graph v of t. The first part, obtain the equation of x of t for an object moving at constant acceleration. So if the object is moving with a constant acceleration, the slope in the graph v of t is constant, because constant acceleration. The slope is the acceleration. So I have v of t, and now this is v0, and now what I pretend, knowing that it's the rectilinear line with constant acceleration, what I pretend is I did something that is almost a trick to find the. I said, imagine this is the t final. So t final will correspond to a v final. We call this v final b also. So what is the slope here? The slope is delta v, and delta v is v minus v0. And here the slope is t minus 0, because I start from the 0, t. This is the slope. So delta v is equal v minus v0, delta t is equal t. And delta v divided by delta t is the slope, is a, the acceleration that they give us. Perfect. So I will say like this. Okay, what is the average acceleration of this motion? What is the average velocity, of this motion? For sure the velocity is changing. It starts at v0, is increasing, but it's increasing at a constant rate. And the constant rate of increasing per unit of time is the acceleration. Okay, what is the average velocity? I don't want to use not v0, not v. I said that the average velocity, v average, is v0 plus v divided by 2. So using the concept of this displacement with constant velocity, we will imagine that the average is the constant velocity. So we will write V average by delta t like our equation. Delta x is V by t. Okay, so delta x is V average by t. Is what we saw yesterday in the previous page for a motion with constant velocity. So delta x V average. V average is V0 plus V divided by 2 by t. I'm introducing the facts that V of t is V0 plus I of t. I would obtain delta x equal V0 by t plus 1 half a by t squared, and here is where I want you to arrive. I wish you good luck in this.